Hello everybody and welcome to today's presentation, How to Monitor Hundreds of APIs in Minutes, brought to you by RunScope. I'd like to introduce you to our presenters. Sam Ibar, who is a Principal Product Manager at CA Technologies. He is in charge of making sure that RunScope customers continue to be delighted. He previously worked at several other technology startups. He has a degree in philosophy and economics from Harvard and an MS in Internet Technology from Pace University. Sam is an ambidextrous ping pong player. And we also have Brian Whitmarsh. Brian Whitmarsh is a Senior Principal Product Manager in the Agile Operations Business Unit at CA Technologies. He has been in the software industry for over 20 years, starting out as an engineer, moving into engineering management, then technical sales and product management. The mobile market is a specific focus for Brian, and he has been in the mobile industry since the late 90s.
All right, so now you see a picture of your two fine presenters today. At least Sam is fine. I'm excited to talk to you today. I love these DZone webinars because we get to talk technical stuff, and we're not going to PowerPoint you to death, I promise. In fact, from an agenda perspective, we only have a few slides. I just kind of want to lead the discussion, talk about API monitoring space. And then Sam is going to be doing the bulk of live demo. It's going to be interactive, it's going to be live, and we're going to show you real solutions to real problems that you're running into today. You notice that I am from Idaho, and Sam is from New York. So we are a distributed team here, and excited to speak with you. All right, from an agenda, again, just a few slides. We do have some polling questions. We want to keep you interactive. No multitasking. This is going to be all good stuff today, and you're not going to be bored. So we're going to give you some polling questions just to kind of understand the audience, understand who we're speaking to. And then also just a few slides to set it up. And then, like I said, the bulk of it's going to be the live demo that Sam is going to provide. And then we'll have a time for Q&A. So with that, we're going to have our first polling question. So Billy, if you wouldn't mind popping up our polling question of the day, the first one, so we can kind of get a better idea of who we're speaking with. All right, and this polling question is really around what is your role? So curious as to the audience today. Are you, the DZone tends to be a lot of developer, a lot of technical focused folks, which is awesome. But also, we may have some folks from management, we may have some QA folks, DevOps, or other. So if you wouldn't mind just selecting that so we can take a quick poll of the audience and understand who we're speaking to today.
I'll close out the poll in about 10 seconds, so answer while you can. And here are the results for the poll.
Excellent. So as typical for the DZone webinars, which is awesome, I love speaking to technical folks. We love showing solutions, getting into the technical bits and bytes. So yep, looks like 80% of you are developers. The rest of you, I promise, will not be bored. We will still keep you entertained and show you some real cool solutions for some of the challenges in today's API market. All right. A few setup slides for you. What is the API economy? In the past, at CA, we've talked about the application economy. We've talked about different types of economies. But really, these days, it comes down to APIs as actually being the true building blocks of applications. A lot of companies, in the past, we would have APIs when somebody would want to integrate two products together. We would, create an API for you. Back in the day, it may have been a SOAP API or a REST API, and then we could create some types of integrations. It wasn't really the mainstay. Today, we have a lot of companies that APIs are really their front or their storefront for other customers to be able to sell their products and services and provide the data that they are using out to the public. And it's a great way also for folks that their mainstay is not building applications maybe. It's building widgets, but they want to sell those widgets, and they don't want to spend their time trying to build a great mobile application or a great web interface. They can then just expose those APIs and say, hey, folks out there that want to be able to provide these products and services can interface with our APIs, and they can create their own rich applications and focus on the application side of it, whereas we're going to focus on what we do best, which is providing those goods and services. So you see a lot more APIs, and especially with the microservices-based architectures these days, that there are more and more what we call endpoints or APIs endpoints out there and available today to be able to interface with. So this is just growing more and more. Now, what happens when an API breaks? In the past, we may have an API, an integration API. Well, it wasn't that important. Okay, yeah, we'll get it fixed, and then the next day, it'll be working again. But now, because so many of these businesses are really focused on providing these services and focused on this is the way they interface, that when APIs break, the whole application experience breaks. Now, here's a few examples. First one is Facebook. Heaven forbid we can't message people back and forth, but when, for example, Facebook's messaging API stopped working, people were no longer able to chat for a period of time. So that was a major connection break between all these other applications out there that have integrated Facebook chat into their applications. All of a sudden, that connection is broken and no longer working. Application experience. I'm a application guy. I love to talk about 5-star experience and how can we improve the usability of applications continually so that we're kind of reading the mind of our customers. And so application experience is big for me. And companies like Tesla have run into issues where, for example, they provide an API for you to be able to, a mobile application to unlock or lock your car or start your car remotely. A lot of car manufacturers do that. And they had an outage a while ago that caused folks not to be able to unlock your car or lock the car. So that's a bad thing. You're out on a date and you can't open the door for your date because the API is down. So that's definitely a bad user experience. Another one is around the fact that real revenue, serious revenue, can be lost. An example here is when the Bitcoin platform experienced some outages around their APIs that they expose. All of the markets around Bitcoin, such as Coinbase, that provide this market, are no longer able to exchange real revenue, and that can cause a serious impact. And we all know if Amazon's APIs went down, we wouldn't be able to purchase our goods and services. So very important that these APIs remain highly available. Now, I told you I'm from Idaho, so guess what? There's not a lot of Teslas running around out here in the country. We do have a charging station. It's only 40 miles away, but this is my experience, right? When an API failure breaks, yes, okay, I do live in a log home. I do live in Idaho. There's a chicken coop in the back, but my log home has some smart devices, and one of those smart devices is my key, the key to get in. It's a digital key. It's not a physical key. And I have this great application that I can send remote keys to and all this. But guess what? When the application might still be working, but if the API call to verify that I can have access to that door fails, I'm going to be standing outside my door. Now, it's a beautiful day right now, but that is definitely, that's how I apply a broken API. Is I would just be locked out of my house, which is not a good thing. So that's one example from the Idaho boy. Now here's kind of a flow of API failure and API breaks. The applications themselves don't necessarily completely break because they're using a bunch of different APIs. but a main, an important aspect of that application, that piece can fail. And then when that fails, you get customers starting to complain. And it can go viral very quickly if you're not able to understand quickly what's taking place and be able to resolve it. So traditionally, the dev team, DevOps team is going to scramble, try to figure out what root cause is. If it's not done quick enough or appropriately, you can really tarnish your brand, and in turn, definitely lose revenue. So very important to make sure that we're able to monitor these APIs. All right, this opens up the second poll question of the day. And Billy, if you wouldn't mind asking this question. This is around kind of tools that you're using today to monitor. And we're just checking to make sure you're still out there and not multitasking too much. So the idea here is, what kind of monitoring are you using today? Traditionally, a lot of us have used application performance monitoring, where we're actually watching the application itself, the whole application. What we're talking about today is the importance of actually, for the individual APIs, making sure that you're monitoring those APIs. And then, maybe you're using both, maybe you're using none, or you're not sure what you're using today. It's fine to say none or not vote. But we just kind of want to get a feel for, are most of you using APM today, or are you using APM in combination with API monitoring? All right, so we'll give you a couple more seconds here just to answer, and then we'll get a feel for where you are from a monitoring perspective. All right, survey says.
There are the results.
Yeah, so this is fairly typical. A lot of the majority, if you do have monitoring, it's going to be API or APM monitoring, and then a lot of folks aren't using anything today, and so hopefully today you'll see the value of that and start to ask the questions as to what monitoring should I be using. All right, back to the presentation. And I promise I only have, I think, one more slide. So this is actually one slide after this. I'd like to talk about the types of monitoring and kind of two key buckets. And we just talked about APM, and we talked about API monitoring. Now, I think of the two different aspects of monitoring. And I like to call it outside-in monitoring and inside-out monitoring. And for inside-out monitoring, that's kind of our traditional monitoring. We place agents on our applications that look at the application. We put infrastructure agents to make sure that the infrastructure the applications are running on are working appropriately. We have API management tools to be able to manage access to our APIs and provide a security layer and make it easy to expose endpoints and all that. And that's really, if you think about it, it's kind of like the behind the firewall. Now, the firewall doesn't mean much today because we all run in the cloud and the traditional firewall. But think of it as kind of like those systems behind the scenes. And that's an inside-out view. And somewhere, if there's a red light going off, there's probably a user impacted. We don't know for sure, but there probably is a user impacted. Now, from the opposite side, I like to talk about the outside in. So it's very important to be able to be kind of sitting in the customer's shoes, and as a user, kind of peeking over the shoulder and looking at how they are interacting. Are they simply smiling or frowning? Are they having a good experience or a bad experience? And that's really where either real-time user monitoring or synthetic monitoring is very important to implement. And that's really what, majority of what we're talking about today is going to be around that synthetic outside in. Let's look as the user's looking, how they're experiencing the interactions with the APIs. And, a couple examples of products that CA has in that zone is RunScope, which you're going to see today. Sam do a great demonstration and solve a real use case. And BlazeMeter is another solution in our API suite that is really around scale testing, the ability to take an API and say, okay, it works great for a few users. How does it work for tens of thousands of hundreds of thousands of users? All right, last slide. 3 pillars. Hopefully, Sam he'll clearly communicate this today, but he'll talk about and show you, simply, basic monitoring is let's make sure that the the API is actually up. And if you saw my T-shirt in the picture, we have this, everything's going to be 200 OK. 200 is the HTTP response code for, hey, everything's hunky-dory, I'm good. But then, it's not just about being good. It's about performing. It's about being quick, making sure you can respond in a quick amount of time. A bad user experience is, even though something's up, it takes 15 seconds or 20 seconds or minutes to complete a transaction. That's bad. Or the ability to make sure that the response that's coming back from that API is correct. A quick response that's incorrect is probably more damaging than not having a response at all. So making sure that you can monitor the actual response and understand that data is coming back, or the format of the data is what it's supposed to be. And if not, we need to get to root cause, figure out and solve that as quick as possible. All right, you're done listening to me. Those were my 6 PowerPoint slides. Now I'd love to switch over and have Sam show you a real live use case. It's specific around, because microservices allow us to have so many different APIs so quickly. How can you monitor these numerous APIs in a short amount of time? All right, Sam, we see your screen, so take it away.
Great. Thanks so much, Brian. So as Brian said, it's very important to be able to monitor your APIs. We saw the picture of Brian locked out of his house. Practically speaking, if you have APIs that have consumers that affect the your brand reputation or drive revenue, if you're not monitoring your APIs, you're potentially risking loss of brand reputation or revenue. And what we hope to show you in the next 20 or so minutes is how easy it is to get started monitoring large numbers of APIs. So for this demonstration, I've got 50 very similar microservices, each of which can receive post and get requests. So this is an API where I can post a message to it, and then the next get request I make will retrieve that message back from the API. And again, we're going to monitor these because we want to know if these APIs are down, or they're slow, or they're returning bad data, because that would create an issue for your API consumer. If by catching the problems first, you can minimize the impact that that any potential outages have, because you're aware sooner and you can potentially mitigate it before a lot of your customers are letting you know that they're having a problem. So how do we get started? Our strategy is we're going to create a monitor for an individual one of these endpoints, and then I'm going to show you how you can replicate that to cover many different endpoints. Obviously, there are many different tools that you can use to monitor your APIs. For this demonstration, we're using RunScope. We're partial to it, A, because we work there, but also because it has a feature set that gives us a lot of flexibility, as you'll see. So let's get started with monitoring our first endpoint. What you're seeing on my screen here is the RunScope dashboard, and all I need to do to create my first monitor is give the test a name. So we'll call it test number 1, and go ahead and click Create Test. This test we're going to create is going to be a 2-step test in which we post a message to our endpoint, and then we get that message to make sure that what we're getting back is what we expect to be back. So we want to know that our API is up, it's fast, and it's returning the correct data. So we're in the RunScope test editor here, and the centerpiece of this is your URL for your endpoint. I'm going to go ahead and drop in the URL for one of my endpoints here. And in a moment, I'll orient you a little more to what's going on here. But all we need to do to start a test potentially is drop in the URL, click Save and Run. And so we've now gone out and made a request to that endpoint. We can click here on that result, and we can drill down and see exactly the request that we made. So we see the headers that were sent. There was no other data being sent. And we can see the response we got back. Now, this test failed because we got a 401 response. We were looking to get a 200 OK response. And we can see the message that the API sent, which is essentially indicating that we were unauthorized, which the 401 response is the code for that we need authentication. And we'll talk about how to do that in a moment. Let me orient you a little more to the run scope editor. A run scope test consists of one or more steps. And within the steps, there are a few different tabs here. This request tab is where we configure the request that we want to send, whether we want to make a GET request, a POST request, or what have you. In the case of our demonstration today, we're going to start this with a POST request to the endpoint. We can add authentication. We can add headers here. So again, for this example, we have a few headers we need to add. So we've got a content type header of application/JSON, and we also have an authorization header, and that I can't type from memory, but I'll grab it and paste it in. We have a body for our request that we're making. So we're going to add a JSON body here. And what our endpoint is looking for is a JSON object with a property of poly says, and then whatever we want to be saying to our endpoint. So we'll just say, welcome to DZone. The assertions tab is where we define the tests essentially that we want to make against the response we're getting. So by default, we've added this 200 response code. We can also add other assertions here about, say, the response time. So we're wanting to make sure that our response time is, say, less than or equal to 500 milliseconds, right? It's important for your consumers of your APIs to get a fast response, because if they don't, they might drop off because they're fearful that the API is not working, or other potential issues. In a moment, we'll add some assertions about what the data looks like, but let me finish giving you a tour here first. The variables tab allows you to assign a variable to use in subsequent steps. So if there's data coming back from the request you make, you can assign a variable to that data so you can then reference it in a subsequent step. And this is, in this case of this test, even though it's a multi-step test, we don't need to do it. But this is frequently used where perhaps you're hitting an endpoint to sign in and you get back a token, and then you need to use that token in a subsequent request. These pre-request and post-response scripts allow you to do more complex data analysis and validation by using JavaScript either before you run the request or after you've gotten the response back. So with the assertions here, we can do basic assertions. With post-response scripts, we could do more complex assertions. Finally, the last thing I want to highlight here is this environment section. These are settings that we can set that run across all the steps in the test. These can include things like initial variables, where we're defining variables to use in all of our steps, and then we can just change it once to affect all of our steps. There are other things here like authentication that runs across the steps, headers. We can set notifications that we want to receive. We'll talk more about this in a moment when we get this wired up, but obviously an important part of monitoring is not just having a test that runs, but a test that will then notify you when it fails so that you can respond quickly. Okay, but let's take what we have now and go ahead and save and run this. And what we can see now is we have a test that's passed. We can see the assertions we were making. We got the 200 response code. Our response time of 15 milliseconds was less than or equal to the 500 threshold we set. And we can drill down and again see exactly the request we made. Here again, we see the headers that we've added of the authorization token and the content type and the body we sent. And if we click on the response tab, we can see the headers we got back as well as what the response from our endpoint looked like. Now, let's go ahead and add an additional assertion here. So we see that we're supposed to have a status property, and we want to make sure we've got a status property of success. So if we go back into the editor, on our assertions tab, we can assert about the JSON body and put in the name of the property, which should be status. And we want it to be equal to success. And again, we'll save and run this. And we can see that again, our test has passed, and our new assertion, making sure that the data looks like what we want it to, passed as well. And obviously in practice, you could do a more complex set of assertions asserting about more properties of data that you're getting. But to keep things simple for the demonstration, we'll just use that one assertion here. The next thing we're going to do is we're going to add a second step to our test. So if I go back to the test editor, I could go down here and add a second request. There are also a variety of other things I could add. I could pause before I made my step. I could wait for an incoming request. So if you have an API where you make a request to one endpoint and then it calls back to a URL you've specified, you could do that here. We could make a conditional step. So basically only if some condition is true, then run the next step. Or we could actually call a completely different test. In this case, I actually am just going to replicate our first step, which I can do here. And then we're going to modify it because we're making a call to the same endpoint and need the same authentication. So I can just go here, change this to a GET request. We already have our authorization header filled in. We don't need the content type. Now let's take a look at the assertions for a moment. Again, we're going to be looking for the 200 status code. We're going to be looking for a response time of less than 500 milliseconds. We don't know what JSON body we're going to be looking for yet because we're not sure what the response looks like. So let's go ahead and delete that assertion, and we can run the test again. And we could either click through to the result and see the result, or we can expand here where it says last response data to see what our response looks like. And we can see that the response we get back includes a status property of success, and then a data property, which includes the name of the service we have, as well as the message that we sent it. What we're going to do is add a couple of assertions about that data that's coming back. And so we want to make sure that we're not going to assert exactly what it looks like. We just want to make sure it contains both the service name, and also make sure that it contains the phrase we sent. If we click Save and Run now, we now have built a two-step test to make sure that we're able to post a message to our endpoint, retrieve that message, and knowing that the API is up, that it's fast, and it's returning data that's accurate.
So Sam, hold on one second. My screen is frozen. Is anyone else's frozen, or is that just me? Could be the drum players out here in Idaho transferring my data. Oh, connection lost. Okay, hopefully everyone else is just fine. I'll let you continue. I'll just rejoin.
All right. If anybody else is having problems, please put it into the chat, and Billy will let me know if anyone else is having a similar problem. Okay. So we've now built the framework of this test. There's two more things we need to do to really make it a monitor that we'd want to use. Now, I mentioned before in our environment, we can create settings about notifications for the test. So we could do email notifications, for example, we wanted. We could do webhook notifications, or we have a variety of third-party integrations like Slack and PagerDuty and a number of others. For this demonstration, we're going to go ahead and configure a Slack integration. So if I go ahead and do connect Slack, this brings me into the interface to add a Slack integration. On the Slack side, I've already chosen to add a run scope integration. And what I get when I do that is a URL. And I can just paste that URL in here. And then I can specify when I want to get notifications. Now, I could be notified every time a test run's completed, but the whole idea of API monitoring in general is to let you know when something's wrong. So I want to set this up so I'm just notified when a test run fails. If I go ahead and do connect account here, I now have this Slack integration available in my test. And this is available in any test that I have in my account now that I've set it up. And so I can go ahead and turn this on, and I could have one or more Slack integrations, across my account. If I have different teams using different channels, I may have different services like PagerDuty or wanting to use email notifications. I can use any combination, but for now, we're just going to use the Slack notification. And I'm going to go ahead and run this test now. And actually, just for a moment, we're going to add an additional assertion to this last test. And we're going to assert that the data property equals foo. And the reason that I'm doing that is because what I'd like to do is see what happens. I'll show you what happens when this test fails. So I'm going to go ahead and run this test. And if I drag my Slack window over here, you'll see, sure enough, I've just gotten a notification here saying that my test number 1 has failed. I could click right from that notification, and if it would open my correct window, it would take me there. It opened in a different window, but here we can see the test result that's got the failure, and so I could know that my data coming back wasn't accurate. Okay, let me go back and take this out. We've now got a test that's going to notify us, and the very final step is to schedule this test to run. So with RunScope, you can create schedules to run your test at frequencies ranging from as frequently as every minute to as infrequently as once a day. For now, we'll set this up to run every 5 minutes. Go ahead and click Save and Run, or sorry, Save Schedule. And we've now scheduled this test to be running on a regular basis. And so every 5 minutes, this is going to go out, hit my endpoint with the post request and the get request, make sure the API is up, it's fast, and it's returning accurate data. Okay, now this has given us a single test to monitor our one endpoint, but you've got dozens or hundreds potentially of APIs that you want to monitor. And the question is how do you get from here to there? And the answer is it's actually pretty easy. What we're able to do is to use this test as a template and then use the RunScope API to programmatically create as many of these as we want. So what does that mean? RunScope has an API that allows you to do everything we're doing through the UI programmatically. And therefore, what we can do is look at what this test looks like and then write a script to create many more copies of it. So if I move over to this tab, I've already set this up. Actually, I'm going to grab the ID for this test that we created. And what I've got here is a request that I'm making to the tests endpoint. And here's an example of using an initial variable to pass something in. So I'm going to make a request to the RunScope API to get the details of what this test looks like. So if I click Save and Run, I've now used the RunScope API to go ahead and query RunScope for the definition, if you will, of this test. And what we can see here is that there's several different objects within, or elements within this object. And we can see things like the steps. So this is the definition of the test we're making. Here's the endpoint we're querying. You can see the headers that we have, the body that we're sending, the assertions that we're making. If we look at the environments header, we can see the integration that we have set up, this integration with Slack, any other settings we have there. If we look at the schedules element, we can see the frequency with which we're running the test and the environment, the UUID that we're using to run that test. And so what I'm going to walk you through doing is kind of how to create a script to replicate this test many times. Okay. In order to use the API to do this, we're going to have 3 steps we need to take because of the way the RunScope API is structured. The first one will be to create the test itself. The second one will be to modify the environment for that test. And the third step will be to define when we want that test to run. Now, we could write this script in any language, but actually you can do this in RunScope. So the first step will be to create the test. And that uses what's called the test resource. And if I tab over here for a moment, this is an excerpt from that test body that we had retrieved using the RunScope API. Now, we're trying to create many different tests, not many copies of the same test. So if we were to just post this body 50 times, we'd end up with 50 copies of the same test. However, there's certain components that we want to change. We want to change the name of the test to include the service we're testing. Maybe we want to change the data we're sending to that endpoint. The endpoint itself changes. Our authorization token may change. And so rather than sending explicit values, what we can do is replace those with variables in RunScope, as I spoke about before when I was kind of walking through the test editor. So if we go back to the editor here, we can see in the body of this request we're making to the test endpoint, we've filled in variables in those various places. I'm going to disable the second and third step. So this first step is the step that we use to create the test. And you can see that we've defined values for those variables in our environment. We also have what we call built-in variables, where we can do things like generate a random string. So this is going to generate a random 12-character string that we use with this test. Now, if I go ahead and click Save and Run here, this should create a new test in our bucket, which is where our tests are stored. And you can see this is the test we've just created. Now, it hasn't run yet. If we edit it and look at the environment doesn't include our Slack notification because we haven't modified the environment yet. But we've demonstrated using the RunScope API to take the template for a test we have and replicate that. So let's go ahead and delete this test. The next step we have is to modify the environment. So we had retrieved data about what the environment looks like. And as you may recall, we just added a Slack integration. And so let's grab this information about what that integration looks like so that we can add it to our environment. And again, if I save and run this test now, and we refresh the page here, you'll see we now have a test, again, that's not scheduled to run, but you can see the environment has been renamed and it includes our Slack integration. Now the final step, let's delete this first, is to schedule this test to run as well. So here we're using the schedules endpoint, and we're specifying the identifier for the environment that we want to use and the frequency with which we want it to run. And if we go ahead and click Save and Run now and return to this bucket and refresh the page, you can see that we now have a test that's in process running. It's just passed its first time. We can see it's scheduled to run every 5 minutes, just as we wanted. Okay, so we've now created a test in RunScope, which is essentially just a script. You could do this outside RunScope, but it's using the RunScope API to create a test that's scheduled to run every 5 minutes. In order
so
to
Sam,
create,
this is something you want if you're developing these APIs. You want to include this script into your automation tool so that when new APIs get created, new tests get created automatically. Correct?
Yep. And now one of the really cool things about RunScope is that you have the ability to actually call a RunScope test from outside of RunScope. We have something called a trigger URL. And so if I copy that trigger URL, and let's go ahead and delete this test we'd created before. If I take that trigger URL and I can just make a GET request there, what this will do is this will externally trigger this test we've just created to create a test. So we can see here we've just run this test, and it's gone out using the RunScope API. It's created the test, it's defined the environment, and it's scheduled it. And if I were to go back here now and refresh the page, we'll see now this third test is back and scheduled and running. What's especially cool with these trigger URLs is we can pass in a bunch of different data. As you may recall, when we created this test, we had a variety of variables that we were assigning. Using this trigger URL, we can actually pass in a whole array of different variables using what we call a batch trigger URL. So let's create a new test. We'll call it batch creator. Batch API creator. And all I need to do is take the trigger URL for my test, make a post request, and then the last thing I need to do is add a JSON body that includes the array of variables I want to pass in. So I've got here a list of all of the different microservices I have, along with their token and along with the test number. These were the variables I defined for my, in that test template. And I can simply drop that in here. And now when I click save and run, this is going to trigger that script we have 50 times using each set of variables. Of course, if I make a mistake, it won't. So my test has failed, but the reason my test has failed is because I was asserting that we were going to get a 200 response. The RunScope API, when you're triggering a batch trigger, actually gives a 201 response. So I've successfully created these tests, but I was not making the correct assertion. If I go back to my dashboard now, what you can see is now I have all of these tests running, many of which have failed, which is fine. We can drill down and see exactly why one of these tests failed. And what I think we'll find is that the responses were too slow. So here we can see that this test failed because the response time was more than the 500 milliseconds. So effectively, we may be load testing my infrastructure by having kicked off 50 tests all at the same time that are hitting the same infrastructure. But obviously, that's valuable to know. And again, for your use case, we've still demonstrated how easy it is to start from an individual test and then replicate it many times so that you can know if any of your endpoints are down, slow, or returning inaccurate data. Hopefully you'll walk away from this appreciating that it's actually quite easy to get started monitoring your APIs. As Brian and I have indicated, it's so important to be able to catch, to be the first to catch when one of your APIs isn't working. And with API monitoring, you can help ensure that you're doing that. With that, let me turn it back. Go ahead, Brian.
Yeah, no, thank you very much, Sam. That was a great demonstration, and we saw how easy it was to create hundreds of monitors. And the key is the ease of it. We kind of showed you a more complicated use case, but starting off, really all you need is a GET request and the URL that it needs to call. And so it makes it very, very simple to get set up. And I have just a couple final slides, and we're going to drop into a QA session. So Billy, if you want to give me control back, I will share my screen real quick.
All right, 1 second.
And that ease of use is so important. To be able to, take a SaaS solution and to be able to instantly be able to have it show value. And that's so I greatly encourage you to try it out. And we actually have a free forever model. If you're just using it to test a low number and you don't want to do scheduled testing, obviously we want to kind of give you a taste of it and show you how valuable it is. Because the key is the first time you catch that API going down before the customers do, wow, it's going to save you a lot of headache. It's going to save you a lot of escalation problems. And so you want to be able to have that monitoring in place to catch those failures quickly. Maybe you have maybe your application has a bunch of third-party APIs that are kind of flaky. You want to know when they are flaky. Maybe you even have SLAs in place with them to say, okay, here's the report. You're not meeting your SLA. Your API was down more often than it was supposed to, and so you have that that information to be able to analytics to be able to say, hey, yep, we need to get a better we need to have a better performance for this application, for this API. Very simple, fast solution. Thousands of customers are leveraging this solution. It's very important for them, and it can be done just by simply going to runscope.com and signing up for a free trial. So I encourage you to go out there, try it out. If you don't have APIs that you can test with, you can simply use, if you look up Deck of Cards API, it's kind of a fun free one out there that you can shuffle the deck and draw cards from the deck, and you can kind of play around with the functionality. Just see how easy it is to work with it and how it's going to add value to your environment. With that, here's our contact information. If you want to email us, if you have questions, we want to address any questions in the last 10 minutes that you might have. So let's go ahead. Billy, what kind of questions are you seeing from the audience?
All right. Our first question is, what happens if I'm working with APIs that return XML and not JSON?
Great, thanks, Billy. I'm not showing my screen now, but in the drop-down selector where we indicated that we wanted to analyze, to make an assertion about the JSON body, you can also select XML instead. So, we support, APIs that return JSON or XML.
Our next question is, how can I minimize false alerts when monitoring APIs?
Yeah, so that's a good question. Obviously, part of the benefit of monitoring APIs is to notify you quickly if something's wrong, but you don't want to be notified falsely about something being wrong. And the internet can be flaky sometimes, and so what we've done to help deal with this is we have a feature that basically allows you to two features that work in conjunction with each other. You may recall when we set up that Slack notification that we set it up to be notified after one failure, but you can actually set it up so you can be only notified after multiple failures. So, for example, you might set it up to be only notified after two consecutive failures. And then we have another feature that works in conjunction with that, where if your test fails once, rather than waiting for the next scheduled test to run again, it will immediately run it again. So that's a good way to avoid, false alerts, from what otherwise is just a one-time blip.
Great. Our next question is, what if my APIs are more complex than what you showed in the live demo?
Yeah, so this demonstration was simple in the sense that all our APIs looked identical in terms of what the structure of the test was and the type of data we were sending and getting back. But the strategy then would be to potentially group your APIs into things that were relevantly similar. So you may have a bunch of APIs that where you're wanting to make a post and get request to, but the assertions look different, and the headers are different and so forth. And what you do then is that set of variables that you have within that template would just be adjusted accordingly. And then maybe you'd have more than one template to address those different, kind of types of APIs.
Awesome. Our last question we have right now is, can I leverage my Swagger or OpenAPI specification to monitor my APIs?
Yeah, you can. So we have the ability to import from a wide variety of different sources, including both Swagger and OpenAPI. Also, if you use things like CA's APIM gateway or the AWS API gateway, you can import from there as well.
Yeah, I think that's an important note. Is that folks are probably going to have, those that have an API gateway already, they're going to have hundreds of endpoints already defined, and so we don't even have to run a script. We can just connect directly to that gateway and grab those endpoints, or take a export file and import those without having to do the scripting and so on. So yeah, it's important that there's a number of different integrations. You can go out and check out the integrations that RunScope already has. So do we have any? How can the audience ask a live question in case there's somebody out there that wants to ask a live question? They have to hit something special on their phone, or what do they do?
If they want to ask a question, all they have to do is put it into the chat panel.
Oh, okay.
Actually, we just got one in.
Okay.
What happens if there's an API changing, or in other words, one API calling another and aggregating response?
I'm not 100% sure what the question means by aggregating the response, but you can, so if by that you mean that you want to use the response from both of those APIs to decide whether or not the test should pass or not, that would be an example of where you could use a post-response script, where essentially after the first step you might set a variable with the data that you're interested in from that first step, and then in the second step you would retrieve that variable and combine it with the information from that second request, and then be able to make an assertion about that aggregated data. If that's what you mean. If that's not what you mean, let us know, and I'm happy to try to address the correct question.
And examples of that is like complex authentication mechanisms for your APIs, where you need to first make a authentication request to an API, and you need to save the response and use that response to get a bearer. So there's it makes it very, very flexible with that scripting component. All right, do we see any other questions at this time?
That is it. Is there anything else you guys want to add before we close?
Well, I just wanted to say thanks to everyone who joined. And if you want one of these cool, everything's going to be 200 OK T-shirts, simply go out and sign up for the trial and send me an email after you've done it. So brian.whitmarsh@ca.com. You just have to go to runscope.com, create a quick account, maybe play around with the deck of cards APIs. Just kind of check it out. Maybe use your own APIs. Send me an email, say you've done it, and we will send. These are these super soft, cool T-shirts. So feel free, if you're an existing customer and you're listening in to Sam, feel free to send us an email, and we can send you one as well. So I just wanted to appreciate you spending some time with us today, and hopefully it was valuable to you. Provide feedback. We're going to do another one of these, so we want to make sure these are informative. These aren't sales pitches. These are to show you technical solutions to current problems that you may be having around API monitoring.
Great. And with that, I would like to thank the presenters today for a wonderful presentation. I'd also like to thank today's sponsor, RunScope, for providing the DZone audience with a great presentation. And I'd also like to thank everyone who joined us today. I hope you learned something new today that'll help you in your career. Have a great day, and we'll see you next time.
Thanks, everyone.